In 1976, an SR-71 Blackbird set two records that still stand today. It flew at 2,193 miles per hour, Mach 3.3, and it reached 85,069 feet, the edge of space. On the ground, the same aircraft leaked fuel through its skin. Crews walked through puddles of JP-7 during pre-flight. The airplane was literally dripping before every mission. This is the story of how that contradiction wasn't a flaw, it was the entire point. And it started not with the Air Force, but with the CIA. In 1959, the CIA had a problem. Gary Powers had not yet been shot down in his U-2, but they already knew the Soviets were developing missiles that could reach 70,000 feet. The U-2's only defense, altitude, was about to disappear. The CIA turned to Kelly Johnson at Lockheed's Skunk Works, the same engineer who had built the U-2. Johnson's answer was radical. Instead of flying higher, he would fly faster. So fast that by the time a surface-to-air missile reached the aircraft's altitude, the aircraft would already be miles away. The result was the A-12, codenamed Oxcart. It first flew on April 26, 1962, from Groom Lake, the Nevada test site the public would later call Area 51. It was single-seat, built for one pilot and one mission: fly over denied territory, photograph everything, and come home before anyone could touch it. But building an aircraft that cruised above Mach 3 meant solving a problem no one had faced before. At those speeds, air friction heats the aircraft's skin to over 600 degrees Fahrenheit. Aluminum loses its strength above 300 degrees. Steel is too heavy. The only viable material was titanium. And in 1960, the world's primary source of titanium ore was the Soviet Union. The CIA set up shell companies, routed purchases through third-world intermediaries, and bought the titanium they needed to build the aircraft that would spy on the country selling them the metal. The cover stories included orders for pizza ovens. Titanium solved the heat problem, but created another one. At Mach 3, the airframe expands. Every panel, every joint, every seam grows as the metal heats. Johnson designed the panels with deliberate gaps between them. At cruise speed, the titanium would expand and the gaps would seal. On the ground, at ambient temperature, those gaps were open, and JP-7 fuel seeped through them. The A-12 flew 29 operational missions under a program called Black Shield, 24 over North Vietnam, 3 over North Korea, 2 over Cambodia. Every mission was flown from Kadena Air Base in Okinawa. Every mission came home. The CIA built 13 A-12s. 5 were lost in accidents. None were lost to enemy fire. On December 22, 1964, the SR-71 Blackbird made its first flight from Palmdale, California. It was the Air Force's version of Johnson's design, stretched, refined, and built for a second crew member. Where the A-12 carried one pilot, the SR-71 added a reconnaissance systems officer in the rear seat to operate the cameras, sensors, and electronic countermeasures that the Air Force mission demanded. The heart of the Blackbird was the Pratt & Whitney J58, an engine unlike anything built before or since. Below Mach 2, it operated as a conventional turbojet. Above Mach 2, bypass tubes routed compressor bleed air around the engine core directly into the afterburner, and the J58 became a ramjet. At Mach 3.2 cruise, the movable inlet spike, which translated 26 inches forward and back to position the shock wave, provided roughly 80% of the aircraft's thrust. The engine core contributed only 20%. The sharp-edged chines running from the nose along the fuselage weren't just aerodynamic. They were an early form of stealth. The chines generated additional lift and improved stability, but they also deflected radar energy away from the transmitting source. The aircraft's skin was coated with iron ferrite radar-absorbing paint. By the standards of 1964, the SR-71 had a remarkably low radar cross-section. By modern stealth standards, it was still a large target, but it didn't need to be invisible. It just needed to be fast. JP-7, the Blackbird's fuel, was engineered specifically for this aircraft. It had a flash point of 140 degrees Fahrenheit, so stable that you could drop a match into it and the match would go out. That stability was essential because JP-7 wasn't just fuel, it was the aircraft's coolant, absorbing heat from the airframe before being fed to the engines. It was also the hydraulic fluid. Every system on the S-71 depended on a substance that most people would call jet fuel, but that was really a thermal management medium that happened to burn. Every Blackbird mission began the same way. The aircraft would take off with a partial fuel load. The leaking panels made topping off on the ground impractical. Within minutes of becoming airborne, it would rendezvous with a KC-135Q tanker, fill its tanks completely, and then accelerate to cruise speed. As the airframe heated and the panels sealed, the leaking stopped. The aircraft that dripped fuel at rest became airtight at Mach 3. Over 34 years of operational service, the SR-71 flew 3,551 sorties. It operated over North Vietnam, the Middle East, North Korea, Cuba, Libya, and along the borders of the Soviet Union. Surface-to-air missiles were fired at it repeatedly. Not a single SR-71 was ever shot down. The standard evasion procedure was simple: accelerate. At 85,000 feet and Mach 3, the SR-71 was moving faster than the effective engagement envelope of every surface-to-air missile system of its era. By the time a missile's radar locked on, guided the weapon to altitude, and the missile arrived, the Blackbird was already 30 miles away. 32 SR-71s were built. 12 were lost in accidents, to engine failures, hydraulic malfunctions, and the relentless stress of sustained Mach 3 flight. None were lost to enemy action. In over 3 decades of flying into the most heavily defended airspace on Earth, the Blackbird's record was perfect. The SR-71 was first retired in 1990. The stated reason was cost. Operating the Blackbird fleet required specialized tankers, dedicated ground crews, and a unique fuel supply chain. Satellites, the Air Force argued, could do the same job cheaper. But satellites have a limitation the Blackbird didn't. A satellite's orbit is predictable. An adversary knows exactly when it will pass overhead. The SR-71 could be tasked and airborne in hours. During the Yom Kippur War, during the Libyan crisis, during every Cold War flashpoint where real-time intelligence mattered, the Blackbird delivered what satellites couldn't: surprise. 3 aircraft were briefly reactivated in 1995 at the cost of $72 million. Congress funded the return. The Air Force resisted. By 1998, the program was shut down for good. Kelly Johnson died in 1990, the same year his greatest aircraft was first retired. He had built 14 distinct aircraft types for Lockheed, including the P-38, the F-104 Starfighter, the U-2, and the entire Oxcart and Blackbird family. The A-12 and SR-71 were his masterwork, not because they were the fastest, but because they required solving every problem simultaneously: heat, materials, fuel, propulsion, radar signature. Each solution depended on every other solution. Today, the fastest SR-71, tail number 617958, sits in the Smithsonian's Udvar Hazy Center in Virginia. On its final flight, on March 6, 1990, it set 4 speed records on its way to its own retirement. It flew from Los Angeles to Washington, D.C. in 64 minutes and 20 seconds. No aircraft has matched the SR-71 speed record in the half-century since it was set. No manned aircraft currently in service operates in the same flight regime. The Blackbird was built to solve a problem that hasn't gone away: the need to see what an adversary doesn't want you to see faster than they can react. The engineering that made it possible was audacious, expensive, and in 1960 probably shouldn't have worked. It worked for 34 years, and nothing has replaced it since.